Similar triangles. And I always find it strange that we do congruent triangles before similar triangles, because congruent triangles are a type of similar triangles. It's just that the ratio of the sides is 1 to 1. So when you're testing for similar triangles, we already know the tests. They are the congruent triangle tests. So tests. Here we go. Corresponding sides are in proportion. Side, side, side.
Can you write that?
Yes. Right? But you don't just write side, side, side. Notice the additional bit. So if you write side, 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 you're implying they're congruent. If the ratio is not 1 to 1, then you write down the ratio. Okay? Two pairs of corresponding sides are in proportion and the included angles are equal. That would be side angle side. But the sides are in proportion. Now, okay. This is the one that's a bit different. Okay? All three angles are the same as the three angles in the other. Angle, angle. Well, that's angle, angle, side in congruent triangles. But because there's only one side, you can't say in ratio because you've got nothing to compare it with in that same triangle. So we just have angle, angle. We don't have angle, angle, side. Yeah.
Can we just write angle, angle?
Yeah. Angle, angle's fine. Some people write the word equiangular. That's fine too. But you could use right angle, hypotenuse, side as well.
Can you say RHS?
RHS in ratio. I mean, you could. So here's one of the classic similar triangle problems where you got one triangle inside the other pair of parallel sides. We've got to find AD. They've given me some measurements. So how would I set this one out? I'd say, okay, well, look, I know DAE and BAC, well, it's the same angle. So I've got a common angle. And EDA and CBA, corresponding angles. I've got two angles. Fantastic. Yes, they're similar. Angle, angle. Now that I know they're similar, I can set up the ratio. When they're nested inside each other, I sometimes like to just draw them side by side so I can see clearly which one matches with which one. So I've redrawn them there and marked in the corresponding angles and that. So I now go, okay, well, AD would be the same as AB. So AD over AB would be the same as AE over AC, ratio of the sides in similar triangles. Now, I don't have to use this, I've gone AD to AB where I've matched them up, or I could have gone in the same triangle. I could have gone AD over AE is equal to AB over AC. As long as I'm consistent in how I've done it, it's still going to work. I mean, you'll notice it's the same fraction because all I would do is there. Let's sub in those numbers, and there it is. AD is 10 centimetres. A couple of things to remember. One of the things you do in junior school, but sometimes we forget, occasionally you get problems on it. Remember, in similar shapes, if you know the sides are in the ratio A to B, then all the measurements are in the ratio A to B. So therefore the areas would be in A squared to B squared, because to find an area you usually multiply two measurements together. To find a volume, you usually multiply three measurements together. So they'd be in the ratio A cubed to B cubed. Hey, that's all I really need to say on similarity. 8H.